Hello friends, welcome back to my channel. Let's code them up. I am Megha, and in our previous video we looked into collections as a whole and array in detail. You can find the link for that video in the description box below. Today we will be learning sets, second part of our collections. The first question that pops up in mind on hearing the word set is, what are sets? A set is just like an array, the difference being that sets have distinct values and no ordering. For example, a set of first four letters of an alphabet A, B, C and D is a set containing distinct values. How do we initialize a set in Swift? Let's open the playground and find it. For example, we will initialize a set containing ages of our friends. In this first method, we do the initialization using initializer syntax, where age equal to set followed by int in open brackets followed by function brackets. Here the variable age of set type set is initialized as an empty set. This set can contain only the integer values as specified by the int keyword. When we print age, we see that it is empty. So we need to add in the ages using age equal to 38, 65, 97 in square brackets. Now, when we print age, we see it has three numbers: 38, 65 and 97. The second method of initialization is using array literals. For this one, we will use an array of colors, where color followed by colon followed by set followed by string in open brackets equal to red, green, yellow in square brackets. The variable color is declared as a set if string values are written using set followed by string in open brackets. The variable color can only save string values as we specified the type as string. Since we used three colors to initialize the set, color set is not empty. In arrays, we use string in double open brackets, but here we use set string in open brackets as set type cannot be inferred only with string in double brackets. Word set is very important to initialize the set type. This initialization can be done using only set, as Swift can infer the type of elements of the set because of its type inference property. First, commenting this initialization, we write var color colon set equal to red, green, yellow in square brackets. Next, we work upon the operations on set. The first operation is inserting an element into the set. For this, we will first insert color blue in the set color using color.in. As soon as I write int, the playground prompts me with some suggestions, and we use this method at the first position and write color.insert blue. We can see here in the result bar that blue has been added to set color. To confirm, we can print color. A difference from the arrays can be seen here. We have not specified the location where we want the blue to be placed because unlike arrays, sets are an ordered list. So blue is added at a random position. The subsequent function is removing an element from the set. For this, we will remove color green from the set and we write color.re. As soon as I write re, the playground prompts me with the options of remove method, from which we select the first method here. So now we write color.remove green. When we print the set now, the result is devoid of green. Now we move on to contain function to check whether an element is inside the set or not. Again, for this first, we will check whether alphabet A is inside set color and then check whether red color is inside the set color. We write print color.contains and in the brackets we write A in double quotation marks. We can see that the result here in the result bar is false as A is not inside a set color. Print color.contains red in double quotation marks. We see in the result bar here that it is true as red is inside the set color. Next is the method to count the number of elements in the set, which is very easy. We just have to write print color.count. Clearly, the answer is 3 as seen here. as our set contains 3 values. Apart from these operations, there are certain operations that can be performed on sets only. The operations that we have studied in maths, like union, intersection, difference, a minus b, and all, etc., etc. Let's see one by one all of these operations. Consider two sets, set A containing A, E, I, O, U and set B containing L, A, U, R, E, N characters. The two circles here denote sets A and B. Since A, E, U is common in two sets, we place them in the intersection of the two circles, and the rest are placed in the A and the B sections. AEU is also the result of intersection of sets A and B. The yellow color here is used to highlight the intersection of A and B. Union operation on sets leads to a set of all elements from A and B. So here union of set A and B will have A, E, I, O, U, L, R, N with A, E, U only once. As we have seen earlier, sets cannot have repeated values, so A, E, U are not repeated. On this slide, the yellow color is used to denote the union of sets A and B, which is pretty much everything in A and B. Symmetric difference, on the other hand, gives values in each set but not in both. Hence, that the symmetric difference between A and B will be O, I, L, R, N. Subtracting B from A will give values in A which are not in B, that is O, I. Now we will perform all these operations in Swift. So let's go back to the playground. We have taken two sets. The first set is the set of vowels containing A, E, I, O, U, and we write where vowels set equal to A, E, I, O, U. And the second set is the set of name letters containing L, A, U, R, E, N, and we write where name letters set equal to L, A, U, R, E, N. The first operation is intersection. For that, we write print name letters dot intersection vowels, and we see the result is AUU as we saw in the previous slides. Next is the union operation, and we write print name letters dot union vowels. The result is all letters in both the sets A, I, R, N, U, E, L, O. The set is not ordered like we wrote in the slides, but this is the same as the set for the union of two operations that we saw earlier. For symmetric difference, we will write print name letters dot symmetric difference vowels, and we get O, L, R, I, N in the result as expected. The last is subtraction, and we write that as print name letters dot subtracting vowels, and the result is L, R, N as expected. With this, we complete sets. In next video, we will cover dictionaries, the last part of collections. And thank you for watching this video. If you have any questions or comments, do leave them in the comment section below. And of course, don't forget to subscribe to my channel for more videos like this. Thank you.